Hey guys, we're going to go ahead and go over those two-step equations that were provided in your Google Slides over our unit on solving equations. We watched some videos on one-step equations, and we've discussed all the simplification of expression tools we're going to use, combining like terms, distributive property. And of course, we threw a couple slides on there about your operations with integers. How do you add integers, subtract, multiply, and divide? A lot of middle school standards. So we're going to get just right into it with two-step equations. We're going to look at this first one that was on our slide. Negative 3n plus 46 equals negative 23. I know my like terms are plus 46 and negative 23, so I need to move that positive 46 to the other side. So I'm going to subtract 46 from each side. That is going to give me two negatives. Now, this is not to get misconstrued with two negatives makes a positive when you multiply. We are adding two negative numbers. So this is like owing two different people two different amounts of money. You owe one person $23, you owe another person $46. You're about to be losing more than either one of those amounts you can see physically. So what I mean by that is if you owe somebody $23 and you owe somebody 46, you're going to combine that debt. You're going to owe that money a total amount to two different friends. So what we do here is if they're both negative, we add the numbers and we get 3 plus 6 equals 9, 2 plus 4 equals 6, and then the rule states that we keep the same sign, and that's how much you would owe combined to those two friends. And just for simple math, negative 23 minus 46 is negative 69. I'm going to bring down the negative 3 in the equal sign. If you notice the positive 46 and the negative 46 here, it cancels out, and that was our goal. We wanted to eliminate that and make 0, and we moved it to the other side. Now we're one step closer to getting our variable by itself, which is our ultimate goal, is to isolate the variable. So now what we have is negative 3 multiplied by n equals negative 69. We are going to divide each side by negative 3. These negative 3s, anything divided by itself is going to give you 1, and 1 does not have to be written down. It can be imaginary. And then if you look at the other side, you're going to have negative 69 divided by negative 3. Now we go back to these integer rules, and this is where it gets a little different. With multiplication division, if you divide a negative by a negative, you're going to get a positive. So these two negatives cancel out. And 69 divided by 3 will give you 23. And that is your final answer to the first two-step equation on our Google Slides. We want to immediately get you guys used to when the variable might be on the right side of the equal sign. So we're going to take a look at that now. My like terms are negative 21 and 9, and our goal is to get that g by itself. So any constant that we can move to the other side, we want to go ahead and do so. But if you move anything from one side to the other, you got to change the operation to the opposite. So the opposite of subtraction is addition. And whatever we do to one side, we have to do to the other. These 21s are going to cancel out again. And then 9 plus 21 is going to give you 30. Now we're going to be careful here. We're not going to just bring down 5g. If you notice, there was a negative symbol there, so we're going to bring that down. So now we have 30 equals negative 5 multiplied by g. The opposite of multiply is to divide. These two negative 5s will cancel out, and it would give us g by itself. And then 30 divided by negative 5, we got a positive divided by a negative. That's going to give us a negative, and 30 divided by 5 will give us 6. And that will be our final answer for g. Negative 6 equals g, or you could say g equals negative 6. Very good. All right, I'm going to go down to this final one. What we have here is we have 15 minus 3x equals negative 6. Now in a second, that minus 3x is going to be looked at like negative 3x. Our goal is to combine our constants, but if they're on opposite sides, when we go to flip one constant from one side to the other, we have to give it the opposite operation or the opposite sign. Now there is a connection between addition and positive, and there's a connection between subtraction and negative. This is a positive 15, so when we move it over to the other side of the equal sign, we're going to change it to a negative 15. But in theory, the way it's written, even though it says it became a negative 15, we're really subtracting 15 from negative 6. So if we go back to our rules of um, subtracting integers, we got negative 6 minus 15. All right, if they're both negative, we're going to go ahead and add the two numbers and we're going to get 21, but we're going to keep the same sign. Remember the money example. If you owe somebody $6 and you owe somebody $15, you owe a combined debt of $21. And O is represented by the negative. I'm going to go ahead and bring down my coefficient, negative 3, and my variable x. This 15 right here, this was technically subtracted from both sides, so this cancels out. This is now 0. That is now 0. All right, we're going to divide each side by negative 3. These negative 3's cancel out to make 1. So what's unique about this is when you cancel out with addition and subtraction, you're going to get 0. But when you cancel out with multiplication and division, you're going to get 1. And those are going to be the two key numbers when canceling out. A negative divided by negative is a positive again, and 21 divided by 3 is 7. All right, great job going over two-step equations. These first three, you were going to add or subtract and then divide. So these types of two-step equations, you're going to add and subtract first and then divide. Now on the other two we're about to go over, you're going to add or subtract, but then you're going to multiply to get the final answer, because the opposite of division is multiplication. Now division look like fractions. We're going to take a look at that right now.